to write the steps. Okay, we will discuss now in the class, all of you write the steps. The 7 steps of hypothesis testing are very important, and you should remember. You should memorize these steps. Okay, in order to do the testing, you should be able to remember all these steps. So it is better if you write. Okay, you all should write it in your copy. What are the steps? Although I will share the link, but still you should write the lines in your copy now in the class. If you're missing anything, I will go on discussing. Okay, by the time you write, and if you miss anything, for that I'm sharing the link on your chat box. Okay, you can see on your chat box now. I am sharing this particular link which you can see on your screen right now. So you can refer to that after the classes. So see, hypothesis testing, I gave you a little bit of introduction about hypothesis, right? When I was teaching you the entire process of research, at that time I gave you a little bit of introduction regarding hypothesis, how it is written, and what are the different types of hypothesis. Okay, basically I told you that time that, if you don't remember, I told you that time that basically we write 2 hypotheses. One is called null and one is called alternative. Okay. So one is null and one is alternative. So at the very first step, we start with stating the null hypothesis itself. Now how this null hypothesis is written, that is described over here. Okay, let us read. The null hypothesis can be thought of as the opposite of the guess the research made. In this example, the biologist thinks that the plant height will be of different for the fertilizers. Now, see, once you do the literature review with regards to your selected topic, you will have some assumption regarding your research results, right? You will have some, suppose you're searching for different literatures and you come across different literature results, so you will have an idea about what result actually you are going to get after doing your research, right? So that is called the guess. Okay, that is called the guess. Now this null hypothesis, when you will write the null hypothesis, this null hypothesis will be the opposite of the guess. That means whatever you will guess, the null hypothesis will be written in the exactly opposite way. For example, one biologist is thinking that the plant height will be of different for the fertilizers. That due to the application of the fertilizers, the biologist is thinking that the plant height will be of different height. Okay, so this is the guess of this biologist. So the null would be that there is no difference among the group of plants. So what is happening over here, you see, you read the lines carefully. The biologist is thinking that the plant height will be different, and he will write the null hypothesis that there will be no difference in the plant height, just the opposite he is writing. Okay, in your example, suppose one of you is doing research and marketing, and you want to establish the relationship. You want to find whether there's relationship between distribution of free sample and the impact of this free sample on the cells. Okay, so after doing quite a number of literature review, you found that there is an impact. There is an impact of the distribution of free sample on the cells. Okay, so this is your guess. Then how will you write the null hypothesis? You will write that there is no relation, there is no impact of the distribution of free sample on the cells. Understood? Is it clear? Please tell me. Is it understandable? Whatever will be your guess work after doing the literature review, you will have to write the null hypothesis in the just opposite manner. Is it clear to all of you? Tell me. Is it understandable? Hmm? Please, anyone, tell me. Ankita, Ayush, Deepa, Shruti, Pema, Pratiksha, Sheetal. Okay. Prashant, Rina, Hulamu, Is it understandable what I'm saying? This is very important to understand, otherwise you will not be able to write the hypothesis in your research work. Simple. Whatever will be your guess, you will write the hypothesis in just the reverse way. Pratiksha, is it understandable? Ayush?
Yes, ma'am.
Pratiksha, is it
Yes, ma'am.
understandable?
Yes,
Okay.
ma'am.
I have told you in a very easy way. Whatever your guesswork is, you will just write it in the reverse way. Okay. So specifically in more study language and null for language that the means I say. Okay. I'm not going to talk about ANOVA at this moment. Okay. You also don't write this line. Specifically in more statistical language, the null for an ANOVA is that the means are the same. Will not write this line, okay, for now. When I will discuss ANOVA in the class, then you can add on this line, but not now. You just write till difference among the group of plants, okay. So then, how will you write it in notations? With the help of notations, you can write it in this way. H naught, this naught or zero will be written in the subscript. H naught is to mu1 equals to mu2 equals to mu3. Since you are saying that there is no difference among the group of plants, then that means the group means of all the plants heights are equal. Okay, when you're saying that there is no difference, that means the means of both the group of plants will be equal of all the group of plants. If there are k number of group of plants, then you can write mu1 equals to mu2. Mu1 means the this is the height of mean of the height of the first group of plant. Similarly, in your case, if you are collecting data for age group, first group is age, suppose. So your first group data will be the mean of all the ages, like that. Okay, it depends on your set of data which you are collecting. So the null hypothesis, when you're stating that there is no difference among the group of plants, then you need to write in notation as h naught is to mu1 equals to mu2 equals to like that till mu k. Okay, for k levels of an experimental treatment. Suppose you are doing the treatment till k levels for k number of groups of plants you are doing, then this you can write in this way. Okay, in your case, I'll teach you how to test hypothesis for two groups only. So mu1 and mu2 will be there. So you will write it as h naught is to mu1 equals to mu2. In statement also you can write it in the way that there is no difference between uh, the mean of distribution of free sample and the mean of the impact on of the free sample on the sales. That means the sales amount. Okay, we will frame the statement in a better way when we will do it practically. Note, why do we do this? Why not simply test the working hypothesis directly? Why not we did not write that there the plant will be of different height? Why simply not like that? Okay, why we're writing it just in the reverse way? Why we're doing it? The answer lies in the Popperian principle of falsification. Karl Popper, a philosopher, discovered that we can't conclusively confirm a hypothesis, but we can conclusively negate one. So we set up a null hypothesis, which is effectively the opposite of the working hypothesis. So this philosopher named Karl Popper, he said that he discovered that he had discovered in his workings that we cannot conclusively confirm a hypothesis. Okay, we cannot go in a direct way. It's like something we are doing it by bending the stick and then we are doing it. Okay, so we cannot directly confirm a hypothesis, but we can conclusively negate one. That means if you are stating that there is no difference among the group of plants, then our task will be to negate it. That means to prove it wrong. Do you understand? We go by this way. We prove something wrong. We don't prove something to be true. This is like that. Okay, we can prove something to be wrong, but we directly don't prove something to be true. So we set up a null hypothesis, which is effectively the opposite of the working hypothesis. That means whatever is your finding, whatever you are assuming, whatever is your guess, So we just set the hypothesis in the opposite of that working hypothesis. The hope is that based on the strength of the data, we will be able to negate or reject the null hypothesis and accept the alternative one. Okay. So what we do? We don't directly prove the alternative hypothesis, but we negate the null hypothesis. That means reject the null hypothesis. And thus we accept the alternative hypothesis. In other words, we usually see the working hypothesis in HA. HA. Now this A, which is written in subscript, is called the alternative hypothesis. Okay. So soon we state the null hypothesis. Our very next step is to state the alternative hypothesis. Okay. The next step is state the alternative hypothesis. I hope you all are writing. If you are unable to cope up, you have missed something, you can refer to the link which is shared in the chat box. Those who have joined late, for them I am again sharing the link in your chat box. Okay. You can refer to this link for writing. But this 7 steps of hypothesis testing should be there in your copy. Just a moment. Okay. So if you have understood and written the null hypothesis, then let us move on to the second step, which is state the alternative hypothesis. Okay. Now, if you're writing that there is no difference between the heights of all the different groups of plants, then alternative hypothesis, you will write treatment level means not all equal. The reason we state the alternative hypothesis this way is that if null is rejected, there are many possibilities. So what we write as alternative hypothesis, we will write this. This has been written in a very critical way, but you can simply write that if null hypothesis is that there is no difference among the group of plants, then you can easily write in the alternative hypothesis that there is difference among the group of plants. Or you can also write as treatment level means are not equal. That means there is difference. Okay. Means are equal, you are writing in null hypothesis. Then means are not equal, you will write in alternative hypothesis. Understood? Why we state the alternative hypothesis in this way? Because if the null is rejected, then there can be many possibilities. For example, mu1 not equals to mu2. But they can be equals to the the other means can be equal. One mean mu1 can be not equal to mu2, but the other means can be equal to mu2. Mu2 means the mean. Okay, mu1 means the mean of the first group of plant, and mu2 means the mean of the second group of plant. So this first two groups of means of the groups can be different, but this mu2, that is the mean of the second group, can be equals to all the other groups. This can be one possibility. Also, the another possibility can be mu1 is equals to mu2, but mu2 is not equals to mu3. That means mean of the second and the third group of plant may not be equal, but other groups of plants means can be equal. Likewise, this way the situation can go on. Many people make the mistake of stating the alternative hypothesis as mu1 not equals to mu2, not equals to mu3, like that, not equals to mu k, which says that every mean differs from every other mean. Okay. Now, some people make mistakes by stating that all the groups of means of all the groups of plants are not equals to anyone else. Altogether they state. Okay, but this is wrong, which means that the mean differs from every other mean. One mean differs from every other mean. This is obviously a possibility, but only one of the many possibilities. This can be a possibility. Okay, But this is also one of the many other possibilities. Other possibilities in the sense, the first two means can only be unequal. The second and third two means can only be unequal. The third and the fourth two means can only be unequal. Like that, there can be many possibilities. To cover all alternative outcomes, we resort to a verbal statement of not equal, not all equal. Okay. So, in order to cover up all these possibilities and simply not stating that all means are going to be different, we come to a verbal statement of not all equal. So, we write treatment level means not all equal. Okay, that means all will not be equal, but also 2 or 3 can be equal. Okay, or not all equal we write, because some may be unequal while others can be equal. And then we follow up with mean comparisons to find out where differences among means exist. In our example, this means that fertilizer 1 may result in plants that are really tall, but fertilizers 2, 3 and the plants with no fertilizers don't differ from one another. Their means may be different. But fertilizer 1 may result in very tall plants, but the other fertilizers may not differ. Okay. A simpler way of thinking about this is that at least one mean is different from all others. So when I will give you only two group of data, here k number of groups of data are there. That's why this becomes a little bit critical. But in your examination, for your research work, only two groups of data will be enough. Okay. And when you will have two groups of data, then what will you write? In the null hypothesis, you will write that the means are equal. And in the alternative hypothesis, you will write means are not equal, because only two group of data will be there. So simply you can write that the two means are unequal. Is that clear? Please tell me. Is that clear? Is that clear? Can I move ahead? Formulation of null hypothesis and alternative hypothesis. Is it clear to all of you? Please tell me. Please tell me. You sleeping beauties, all sleeping beauties, sleeping at 8 a.m. Wake up and tell me. Okay, Ankita is telling, yes ma'am. Others? What about you? Is it clear? How do you state null and alternative hypothesis? All are sleeping, except Ankita.
Ma'am, can you explain a bit of the alternative one, ma'am, please?
No, ma'am.
Okay. Pema, what did you say?
No, ma'am, we are not sleeping, ma'am.
Oh, you're not sleeping. So have you understood? Alternative hypothesis, see, Ayush, this is a statement where, we are taking k number of fertilizers and saying that applying the fertilizers, the height will differ amongst the plants. Okay. So we are applying k number of fertilizers. That's the reason that we are saying that one case can be the mean height of the first group of plant is unequal to the mean height of the second group of plant. But this mean height of the second group of plant can be equal to all the other means of the other group of plants. Okay, where different K type of fertilizers are being applied. K means 1, 2, 3, several numbers. 10, it can be 10, 20, 30, 40 like that. Okay. So, one possibility can be the first two are only unequal, but the rest of them are all equal. Second possibility can be the mean height of the second group of plant and the third group of plant are only unequal, but rest are all equal. Likewise, it can go on. Like we can also say that mean height of the third group and the fourth group of plants are only unequal, rest are all equal. Like that we can go on. So there can be many possibilities. What I am saying is, when I will give you sums to solve and you will also do your research work, you will only have two group of data. Say first group is the age of people and the second group is the height of people. Okay, so age and height, you want to find out the relationship between these two, whether there exists any relationship or not. So you will state the null hypothesis as that the mean of the age of different people, or say, let us put it in different way. Okay, two group of people, okay, two group of people having two sets of data related to height. Okay, so one group is of the age, say 18 to 25 years, and another group is say 25 to 40 years. Two group of people, okay, two group of people having two sets of height data you have collected. Okay, now you want to test whether there is any relationship. So how will you test? In null hypothesis, you will state that the mean height of the first group, that is 25 to 40 years, sorry, 18 to 25 years, and the mean height of the second group, that is 25 to 40 years, are equal. So that will be your null hypothesis, are equal. But you know that the mean height of 18 to 25 years and the mean height of 25 to 40 years are not going to be equal. They are going to be different. You know this from your literature review, you have known this. Okay, so what will you write is, in null hypothesis you will write that the mean height of the first group of people is exactly equal to the mean height of the second group of people, which you want to prove wrong. Okay, which you want to prove wrong. So in alternative hypothesis you will write that the mean height of the first group of people is not equals to the mean height of the second group of people. Is that clear? Is that now understandable?
Yes,
Little bit?
yes, ma'am. Yes, ma'am. It's
Okay.
clear.
So here you are just messing up because there are k number of group. K number of fertilizers have been applied. So this is a little bit of critical example. But listen to my words that when you will do your research or when we will solve the problems, we will only have two set of groups, two set of data. So in that case, simply you will write the null hypothesis as the mean of the first group is just equal to the mean of the second group, which you want to prove wrong. So in alternative hypothesis, you will write that the mean height of the first group is not equals to the mean height of the second group. Simple. Okay, we will do sums on this, so then it will be more clear, for you. Okay, so only one more step we will do today, and the rest of the 4 steps we will do tomorrow. Okay, so third step, once you are done with stating the so when you will receive the problems, when you will receive the problems, and in your real life research also, when you will do the literature review, you will have some data with you, you will have some assumption with you related to your result, which topic you have selected. Related to that topic, you will have some assumption regarding the result of it. So as soon as you have the assumption, start writing the null hypothesis. The null hypothesis will be just the reverse of your assumption. If you are assuming that there is relation, then in your assumption, in your null hypothesis, you will write there is no relation. Understood? Just the opposite you will write. Similarly, in alternative hypothesis, you will write your assumption. That means the opposite of the null hypothesis now you will write. If null hypothesis you are writing, there is no difference. In alternative hypothesis, you will write there is difference. So done, 2 steps are done. Then in the third step, you need to set the level of significance. This alpha, what you can see right now on your screen, step 3, set alpha. This alpha is called the level of significance. Okay. So if we look at what can happen in a hypothesis test, we can construct the following contingency table. So now see, we can prepare this contingency table. Okay. In reality, that means after testing, that is we are writing in reality. And here we are writing the decision. Suppose the decision after testing, there are techniques to test, okay, which I'll teach you gradually. So there are formula which I'll give you, and you will learn that formula and solve the problem. Okay, solve the set of data's problem given to you. After using the formula, you will be able to state whether the null hypothesis can be accepted or rejected. Okay, mathematically there is a rule to state. So suppose after applying the formula and testing the hypothesis, your decision is that accept H naught, that is accept null hypothesis. Okay, and in reality, it can happen sometimes. Okay, it can happen sometimes that mathematically you are getting one result, but in reality the result is different. In reality, the result is COVID cases are increasing sharply in an exponential rate. Every day it is increasing by say 1000 numbers. Okay, reality. But after testing your result, whatever data you have collected, maybe there were some mistakes in calculating the data or in collecting the data, and in this, as per your mathematical calculation, the decision is showing that there is not 1000 number of increase in COVID cases, but only 100 numbers of increase in COVID cases. So decision can vary with the reality. Okay, now if it is not varying, then you are accepting, suppose H naught, your H naught was one statement, you have accepted that, and reality also H naught is true, then okay, no problem. Okay, see, look at this table. Okay, follow my arrow. When you are and in this table, in this block, then H naught is true, and also you have accepted H naught, then it is okay, no problem. But in reality, suppose the H naught is false, but according to your calculation, you are accepting H naught, then it means you are doing type 2 error. Okay, remember this may come in your examination. Explain type 2 error. So type 2 error is when you accept the H naught when it is in reality false. In reality it is not true, but you have to accept it as per your calculation due to some misinterpretation of result or miscalculation of the using the formula, or not properly collecting the data. Due to that you have accepted the H naught, but in reality H naught is not to be accepted, it was false, then you are conducting type 2 error. Okay, then you are conducting type 2 error. Then come to this block where type 1 error may occur. Type 1 error may occur when you reject H naught, whereas in reality it was true. Okay, this is called type 2 error. Then come to this block. If H naught is false and you are also rejecting H naught, then okay, no problem. You should be familiar with type 1 and type 2 errors from your introductory course. So this site is talking about some course, that's why it's talking about some course. Okay, but you at this level you should be familiar with type 1 and type 2 errors. Okay, type 1 is what? When you reject H naught when it is in reality true, and type 2 is you accept H naught when in reality it is false. Okay, so it is important to note that we want to set alpha, that is level of significance, before the experiment, because the type 1 error is the most grievous error to make. The typical value of alpha is 0.05, establishing 95% confidence level. Okay, now see this value of alpha, you write it in your copy. Okay, it's not there in your screen, you write it in your copy. The value of alpha can be 0.05 or 0.01. Okay, write down the value of alpha can be 0.05 or 0.01. Okay, if you are taking the value of alpha as 0.05, then that means that you are having 95% confidence level in your decision. 95% confidence level means 95% you know that you are correct. Okay, 95% means 95%, up to 95% you think that you are correct. And when you are taking the value of alpha as 0.01, then it means that you know that you are 99% correct. Do you understand? So it is generally we take the value of alpha as 0.05. Okay, but 0.01 is always better, because when you are taking 0.01, it means that you are 99% confirm that your answer is correct. Okay. So I'll teach you how to apply this 0.05 and 0.01. But for now, you understand that step 3 is to identify the value of alpha, that is level of significance. And we normally take the value of alpha as 0.05. That is 95% confidence limit. Okay. All right. We will discuss it further tomorrow. Okay. For now, you give me the attendance. You respond. Ayush Pradhan, Abhishek,
Present,
Ankita,
ma'am.
Ankita,
Present, ma'am.
Orgho, Ayush Chaurasia, Bikram,
Present, ma'am.
Bikram.
Present, ma'am.
This is Deepa.
Yes, ma'am.
Okay, Divesh, Diksha, Isha, Hemant, Jasmeet, Landu, Pema,
Present, ma'am.
Hulamu,
Present, ma'am.
Pooja, Prajwal, Praraj, Prashant, Pratiksha,
Present, ma'am.
Pratiksha, Prayas,
Yes, ma'am.
Prayas, Raj, Rajeshwari, Ronak, Reena, Ritik, Sahil, Sejal, Sheetal,
Present, ma'am.
Shruti,
Present, ma'am.
Shubham, Sparsh, Srishti, Svikar,
Present, ma'am.
Valusha, Wangchu, Yogesh, Yongthen. Okay, you can leave the meeting and we'll discuss it further tomorrow. Okay.
Thank you, ma'am. Have a good day, ma'am.
Thank you, ma'am.
Thank you.